The theory I might have studied like that, but here you are using statistics or sample survey. Here to value of pi, suppose you take a circle of radius 1, then its area is equal to pi into 1 square. It's equal to pi. So we can define the value of pi as the area of a circle of unit radius. And to find this value of pi, this Monte Carlo method, what we do is that we draw a circle with 1 meter or 1 centimeter or 1 unit as diameter. Then you have a unit circle. Then enclose the circle in a square of side 2, because this side will be from center to this is 1 unit, and from to this also it is called unit. So now we have a square of sides 2. And you know the area of this square is equal to 2 into 2 is equal to 4, and area of the circle is pi. Now we are distributing a large number of, say, some very fine spheres. Come this sphere. We are taking say 1,000 small globes or some small materials like that, and spread it along this, completely uniformly spread it along this area, and count that objects, for example stone pieces maybe like that of globes inside this circle, and also the total we know. Now the area of the circle is proportional to the number of objects inside it, and the area of the square is proportional to the total number. Now we can calculate these ratios, we can find out the value of pi. So we have seen enclose a circle in a square of side 2 unit area. For that you have already seen, and we generate two sets of random numbers using a Python program between -1 and +1. You know, I had told you that the numeric Python will give random numbers between 0 and 1, not between -1 and 1, but we can make them equal to between -1 and +1 by a very small formula that I will show in the bottom. Now, let us suppose the total number is equal to n, x is equal to n, and y is equal to total random numbers we are using. Now, count the numbers which satisfies this relation. That is, this equation for that is x square plus y square is equal to 1 unit radius. So, you count all the points which satisfies this x square plus y square is equal to less than 1, because all particles of this or numbers of this size will be lying within the circle. Then the area of the square A proportional to the total number n0 of the random numbers, and area of the circle pi proportional to n. See here, total number is equal to n0, then this area that is equal to 4 will be proportional to n0, and this area is equal to pi, and this is proportional to n. So we have a is proportional to 0 and pi is proportional to n, and divide this ratio, we have pi by a is equal to n by n0, or pi will be 4 into n by n0. So you see the Python program, since it is a very simple program, I have given here. So we have generated, see, x is equal to, we are using numeric Python. X is equal to -y plus 2 into random n0. N0 is a random number, maybe 1,000, 10,000 or 20,000 like that. Depending the value of n0, you will get more accurate. So here, -1 plus 2 into random n0. That is random numbers between -1 and 1. I told you the random number generated by numeric Python is between 0 and 1. Suppose the random number is equal to 0, then what happens? This is equal to minus 1 plus 2 into 0. It will be equal to minus 1. So the lower limit of the run-over generator will become minus 1. And the maximum value generated by Python will be 1. And then that will be minus 1 plus 2 into 1. That is 1. So the upper limit will be now 1. Now you get random numbers between minus 1 and 1. And y is also like that, random numbers between minus 1 and 1. So you get two sets of random numbers. Now this is the initial number. We are generating x1 is equal to 0, a row with n number of rows. It's an array with n number of zeros, and y1 is also a number of zeros. Only to plotting the graph. Now we are counting the number. Initially counting 0 for j in range n0. The total count we are taking is n0 numbers to count xj square plus yj square is less than 1. We are increasing the count by 1. Then we take the final value of the count and divide it by the total number and multiply with 4. You get the value of pi. This can be repeated. For each repetition, you will getting slightly different value, and also when you increase the value of n, you will get more accurate result. See in this graph, see you cannot see the points because the number of points are very closely packed. You can try by trying a number n is equal to 1000. You can see large number of dots here and there. You take then it is equal to 5000. Number of dots will be very large, so that will become smaller and smaller like that. And you can go 5000 or 10,000 like that. This way you can repeat the value and find out the average value of pi.